The butterfly effect is a fascinating theory that has captured the imaginations of scientists, philosophers, and artists alike. It suggests that a small, seemingly insignificant event can have far-reaching and unpredictable consequences, much like the flutter of a butterfly's wings causing a hurricane on the other side of the world. While it may sound like science fiction, the butterfly effect has been studied and observed in a wide range of fields, from chaos theory and physics to psychology and economics. This is the mesmerizing concept behind the butterfly effect, a phenomenon that illustrates the interconnectedness of everything in our universe. The butterfly effect is a notion in chaos theory that explores the idea that small changes in initial conditions can lead to significant and unpredictable effects on complex systems. In other words, even a tiny variation in the starting conditions of a system can cause vastly different outcomes over time. But what exactly is chaos theory? Well, it is the study of how small changes can have big effects over time in complex systems, such as weather patterns, the behavior of planets, and even the stock market. It's like a game of Jenga. Removing just one block can make the whole tower fall. In the same way, a small change in one part of a system can have a big impact on the entire system. Chaos theory helps us understand how these systems work, even if they can be hard to predict. Now, moving back to the butterfly effect, in order to understand it, it is helpful to consider this example. Imagine a weather system that is highly sensitive to initial conditions, such as the position and temperature of the air masses in the system. If a butterfly flaps its wings in one part of the world, it may create a small change in the atmosphere, such as a tiny air disturbance. Over time, this disturbance can grow and spread, interacting with other air masses and potentially leading to much larger changes in the weather patterns. One of the key insights of the butterfly effect is that many systems are highly sensitive to initial conditions. This means that even slight changes to the starting state of the system can cause significant changes in its behavior over time. The classic example is that of a double pendulum, where the movement of the second pendulum is highly sensitive to the initial position and velocity of the first pendulum. This sensitivity can make it difficult to predict the behavior of complex systems over time, as even small errors in measurement or modeling can lead to vastly different outcomes. Another example can be seen in the prediction of the weather. A small change in temperature or pressure at a particular location can set off a chain reaction of events that leads to a very different weather pattern than would have occurred otherwise. This is why weather forecasting can be so challenging, as even small uncertainties in the initial data can lead to significant errors in the predictions. Despite these challenges, researchers have made significant progress in understanding the butterfly effect and its implications. By studying the behavior of complex systems over time and identifying the key factors that influence their behavior, scientists have been able to develop models and tools that can help predict the behavior of these systems with increasing accuracy. Now that we know what the butterfly effect is, let's take a brief look at how this concept got its fascinating name. The term butterfly effect is often attributed to the American mathematician and meteorologist Edward Lorenz, who first introduced the concept in a paper presented to the New York Academy of Sciences in 1972. Lorenz, who was working on weather forecasting models in the 1960s, discovered the butterfly effect while experimenting with a simple computer simulation of weather patterns. He found that even tiny changes in the initial conditions of the simulation, such as rounding a number to a different decimal place, could lead to drastically different weather patterns over time. In a now famous example, Lorenz found that a small change in the starting values for temperature and wind speed in his simulation could lead to a hurricane forming or not forming several weeks later. He realized that this kind of sensitivity to initial conditions could make long-term weather forecasting extremely difficult, if not impossible. Lorenz used the term butterfly effect to describe this phenomenon because he believed that the flap of a butterfly's wings in Brazil could set off a chain of events that might eventually lead to a tornado in Texas. He used this metaphor to illustrate the idea that small actions can have large and unpredictable consequences. The concept of the butterfly effect has since been applied to a wide range of fields, from economics and finance to biology and ecology. It has also been used in popular culture, with references to the butterfly effect appearing in movies, TV shows, and books. In conclusion, the butterfly effect is a fascinating and thought-provoking concept that challenges our understanding of cause and effect and reminds us that even the smallest of actions can have a ripple effect that extends far beyond what we can predict or control. The butterfly effect has captured the attention of scientists, artists, and thinkers across disciplines, and continues to inspire new research and insights. It challenges us to consider how seemingly insignificant actions can have far-reaching consequences, and how complex systems can be influenced by even the smallest of changes. The idea that small actions can have significant and far-reaching consequences is both empowering and humbling, and reminds us that we are all interconnected in ways we may not fully understand. As we continue to explore the mysteries of the universe, the butterfly effect serves as a reminder that even the smallest things can make a big difference.